Hello again, guys. We're still in our unit dealing with triangles, and now we're going to be discussing medians and altitudes in lesson 13.4. So please make sure you've got Pearson up at the same time as you're watching through my video. What you don't realize is we have already been dealing with medians. You just maybe haven't known their name. So the median of a triangle is the line that goes from the vertex to the midpoint of the opposite side. Of course, I can't go from the vertex to the midpoint of a side that I'm touching because then that would just be part of the edge. So I go from the vertex to the midpoint of the opposite. And the other thing is the three medians of a triangle are always concurrent. Hopefully you remembered concurrent means they will all three meet in the same point. Here's the cool thing that happens at this point of concurrency. First off, let's go ahead and give that a name. So that point of concurrency is the centroid of the triangle where all the medians meet. But what happens is it splits my medians. So my median here, FH, if I split it up into FC and CH, FC is 2/3 of the length, while CH is 1/3 of the length. That will hold true for any of these. So from D to C is 2/3, and then CJ is 1/3 of that total length. Same thing from E to C, and then C to G. You always know the longer one because it connects the centroid to the vertex of the triangle. That's always going to be the 2/3 section. The other really cool thing that happens is this centroid we also know as the center of gravity. That's why we call it the centroid. It's the center of all of the weight. So if you find the centroid of a triangle, so you have a piece of wood or metal or whatever, that is the point where it will balance perfectly. Please make sure you've worked through the first problem set in Pearson and come back when you are ready for the got it. Alright, so when we set up our got it, we see that ZA is 9. So ZA is this segment right here coming from the vertex to our centroid. And then we want to know the entire length of ZC. So what we know is because this is the centroid, that is going to be ZA is 2/3 of ZC. So ZA is 9, and that's 2/3 of ZC. Well, it tells me to multiply. Because I have a coefficient that is a fraction, I know I can get rid of that by multiplying by its reciprocal. So I can multiply by 3/2 on both sides. That leaves me with just ZC on the right, on the right side. And I have 9 times my 3/2 on the left side. I get 27/2, or 13.5 for the total length of ZC. So we're asked about the ratio of ZA to AC. Now ZA is the length that was originally given as 9, and AC is the remaining length to talk about the whole segment. Now we found the entire segment ZC to be 13.5. Well, because of that, I can know that ZA was 9, so AC must be 4.5. We can use the simple substitution property there, or subtraction property. A few different ways we can get around that. So if I set up this ratio of ZA to AC, it's just 9 compared to 4.5, which really simplifies down to 2:1. Now, if you want the more complicated method of seeing that, here is the answer for B all written out. But what we'll see is this relationship will always hold true. Since this is 2/3 and the shorter section is 1/3, the ratio is always 2:1. Pause the video to try numbers 1 and 2 and come back when you're ready for the answer. So here in number 1 and 2, we start out by knowing that YU is 3.6, and we are first asked to find ZY. What we know is that YU coming from the vertex to that centroid is going to be twice as long as from the centroid to the edge. So this distance of 3.6 is twice as long as YZ, which makes YZ 1.8, and then when I combine them for the entire ZU, I get 5.4. If you haven't done number 2, please do that now. When we're looking at VX, VX is the entire median from vertex V down to our midpoint X. So we know that VY will be 2/3 of the total distance, and YX will be 1/3 of the total distance, which then tells me that VY is 6 and XY is 3. So there are all of your answers for that. Now we're going to start talking about an altitude of a triangle. Now when you think of altitude, what you probably think of is how high something is in the air, like the altitude of a plane. Now that is very similar to what you want to think of, because we're thinking about perpendicular distance, or the perpendicular line. So it's the perpendicular segment from a vertex to the line containing the opposite side. So that's a little bit confusing, to the line containing the opposite side. That is because an altitude can be inside, which is easy to draw, or it could be outside, which is where it will be the line containing the opposite side, or it could actually be one of the sides of the triangle. So down here in the got it, check out what you think for A, B, and C. Are they a median, an altitude, or neither? EG, the line across the middle of our triangle here, well, E is a midpoint of AC, but G, we don't know anything about G, so this could possibly be a midsegment if AG was congruent to GB, but since we don't know that, we don't have a specific name for EG, it is just a segment. And then CF goes from our vertex perpendicular to the opposite side. There's nothing special about where it hits over here, just that it is perpendicular to the vertex, so that makes it an altitude for us. There's your answers written out in just a slightly different manner. For 3 and 4, pause the video and think about what is the segment shown. So I went ahead and gave you one clue. We have a midpoint given to us here because we have congruent segments. We have perpendicular over here, but what can you determine these lines are called? So there you go. In 3, this line is nothing special. We do not have a name for it because it comes from a midpoint on one side to just a random location on the other side. In number 4, we have it coming from a vertex down to the opposite side, and it meets in perpendicularly, so that tells me that it is in fact an altitude. So quickly, I'm going to jump back here to remind you that the point of concurrency of the medians we call the centroid. But now we're going to talk about the point of concurrency that contains all the altitudes, and that we call the orthocenter of the triangle. So where all 3 altitudes meet, because all 3 altitudes will be concurrent, where they meet will be the orthocenter, and this again could be inside, on, or outside of the triangle. So again, in our got it here, it will be helpful for us to put this on a graph. So I go ahead and graph these points to make the triangle, and then find the coordinates of the orthocenter, which again comes from the altitudes. Alright, so when we're looking for the orthocenter, we need to use our altitudes. So we know that an altitude comes from a vertex perpendicular to the opposite side. So if I start at this vertex and I want to go perpendicular to the opposite side, well, I have to actually be right there on the baseline. Likewise, if I start from this vertex trying to be perpendicular to the opposite side, I have to be right on the line so that I can be perpendicular. So just with those 2 altitudes, I can find that my orthocenter is actually this last point right here, which would also show me that if I go from that point perpendicular to the other side, it will have my 3rd altitude meeting with my other 2, so my orthocenter is at 1, 2. So there we go, at x value of 1, y value of 2. Go ahead and try 5 and 6 on your own. Again, it would be very helpful to graph these. So in 5, again, once I put this on the graph, I see that I actually have a right triangle. So if I come from this point perpendicular to the other side, again, it runs right along the side. Same thing from this point, vertex. And I see that my orthocenter is actually going to be at 4, 0. All right, number 6 is one of those situations where we have to use the part of the definition where it said the line containing the opposite side. So let's start right here from our point C, which I forgot to color code. There's C. So if we start from that point and we want to draw our altitudes, I need to go perpendicular to the other side. So that would be one of my altitudes. From here, I would need to go perpendicular to the opposite side. Right there. And don't fall into the trap of just going one direction, because as you see here, if I only extend this line this direction, and I only extend this line this direction, they'll never meet. So I need to also turn around and take this the opposite direction, out that way. And when I draw my altitude for this side, it has to be perpendicular to the line containing my opposite side. So again, I need to extend the sides. And I find that my point of concurrency, my orthocenter is actually out here And based on how I cut the graph, it's a little hard to see what the point is. But if you did it right, it should be -2, 0. So I'm slightly higher than I should be. A couple of these are probably not perfectly perpendicular, which is why it's sometimes easier when you're working on paper and you can have a protractor readily accessible to check that you're actually running at 90 degrees. I bet you this line right here is not quite a 90-degree angle. So there we go, I fixed my lines to try to make them a little bit more perpendicular, and I am now on that point, -2, 0. This page right here is so important. So this part of your notes should get highlighted, starred, something so that you can refer back to it to remember what point matches what lines it came from. So perpendicular bisectors meet at the circumcenter, because remember we can circumscribe a circle, and it is also the then angle bisectors meet at the in-center, because it will always be in the triangle. My medians meet at the centroid, and my altitudes meet at the orthocenter. So now to wrap up our lesson, try 7 through 10 completely on your own. Pause the video, come back when you have all of your answers ready. When we think about whether AP is a median or an altitude, we see that it goes to a midpoint, or the middle of our other opposite sides. We know that makes it a median. When we look at trying to find KP, we know that because these are both midpoints, that this is my centroid. Remember to bounce back here if you need. My medians meet at the centroid. So that tells me that AK is twice as much as KP, or that KP is 1/3 of the total. So that then tells me that KP is 6. Since I still know that K is my centroid and that BQ is another median, I know that BK is going to be twice as much as KQ, or that KQ is going to be half of BK, so KQ is going to have to be 7.5. And when we're looking for altitudes, we must come from a vertex point to the opposite side perpendicularly. So what we see is from my vertex point perpendicular to the opposite side is right there. From my vertex point perpendicular to the opposite side is right there. So AB and AC are both altitudes in this triangle. So that is all I have for you guys for today's lesson. Please make sure that all of this makes sense. Let me know if you need any help with anything, and I will see you guys in class. Have a wonderful day.